Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Quick fact to start. Last year's examiner report showed one of the most common lost marks came from to 2 decimal places questions, not because the maths was hard, but because students didn't write the bounds. If you've ever had an answer marked wrong even though it felt close enough, this episode will fix that.
Sound familiar? I remember getting full marks on calculations, but then failing the bounds part. Why do examiners care so much about this?
Great question. Bounds are how examiners handle rounding and measurement uncertainty. They want to know the range of possible values for a rounded measurement. If you can write the correct range, you often secure method marks, even when your rounded final number is slightly off. That's the bankable marks idea.
Right. Let's explain the core idea step by step. First, what is a bound? If a measurement is given as 3.45 to 2 decimal places, that number stands for any actual value that would round to 3.45. So we find the smallest value that still rounds to 3.45 and the largest value that still rounds to 3.45, and those are our lower and upper bounds.
In classroom terms, take the last digit you were given, here it's the 5 in the hundredths place, then split the next digit. For 2 decimal places, you split at 0.005. So lower bound is 3.445 and upper bound is 3.455. But important, the lower bound is written as less than or equal to, and the upper bound is less than, because 3.455 would round up to 3.46, not 3.45.
So we write it as 3.445/x less than 3.455. Notice the lower bound is inclusive, the upper is exclusive. That tiny detail is where students lose marks. Let that sink in.
Okay, that's for decimal places. What about significant figures? I always mix those up.
Good point. For significant figures, you do the same idea, but the size of the gap depends on the place value of the last significant digit. Example, 2.36 to 3 significant figures. The last digit is in the hundredths place, so the bounds are 2.355 less than or equal to x less than 2.365. For one significant figure, like 5 to 1 SF, bounds would be 4.5 less than or equal to x less than 5.5.
One more example I use in class, percentages. If a percentage is given as 12.3% to 1 decimal place, then the bounds are 12.25% less than or equal to p less than 12.35%. Same rule, different units. It always comes down to half of the unit in the final place.
Now, here's why this matters in calculations. If a question asks for a value that uses a rounded measurement, for instance an area, perimeter, or a percentage change, the answer should often be given as an interval based on the bounds. If you plug in the bounds and show the method, you can pick up method marks even if your final rounded number is slightly off.
So, how do examiners award marks on these questions? What exactly should I write to maximize marks?
Here's the examiner breakdown. Typically, a bounds question will be worth 2 or 3 marks. Mark allocation often looks like this. M1 for writing the correct lower and upper bounds for each measurement used, M1 for using those bounds correctly in the calculation, and A1 for the final answer if it's correctly simplified, or the correct interval is stated. Sometimes the final accuracy mark is split, but the common pattern holds. Method first, accuracy last. Write your method and you bank marks.
Common mistakes I see. Students write 3.445 less than x less than 3.455, so they make both bounds exclusive. That loses the lower inclusive mark. Or they forget to show the bounds at the start and just give a single rounded value. Examiners want to see the interval or the inequality. Write it down, don't just think it. Let's do a worked example live. Question:
A metal rod is measured as 4.12 meters to 2 decimal places. A second rod is 3.7 meters to 1 decimal place. Find the possible range for the total length of the 2 rods. First step, write bounds for each measurement.
For 4.12 to 2 decimal p, bounds are 4.115 less than or equal to L1 less than or equal to 4.125. For 3.7 to 1 decimal p, bounds are 3.65 less than or equal to L2 less than or equal to 3.75. Always show those inequalities. That's your first M1.
So, for the total length, we add the lower bounds to get the minimum and add the upper bounds to get the maximum, right?
Exactly. Minimum total equals 4.115 plus 3.65 equals 7.765. Maximum total equals 4.125 plus 3.75 equals 7.875. But note the upper bound is exclusive, so we write the total as 7.765 less than or equal to t less than 7.875. That full set of steps, bounds, calculation, final inequality, is what secures M1, M1, A1 in many mark schemes. Also point out, don't round intermediate answers too early. Keep the exact bound additions and only round the final interval if the question asks for a specific accuracy. Showing exact inequalities preserves those method marks. Common pitfall: mixing inclusive and exclusive signs. Remember the rule: lower bound inclusive, less than or equal to, upper bound exclusive, less than. Why? Because the exact upper bound would round up to the next number. Say that out loud in the exam if it helps. Upper bound excluded because it would round up.
I like that. Can you give one quick habit I can use every time I practice so I stop losing marks? That's your quick win. Habit: annotate the rounding point on the question. Write the bounds immediately beneath the given value and add a short comment like upper bound excluded as it rounds up. Do this as your first 2 lines of working. It takes 10 seconds and catches about 90% of rounding errors. Don't skip the check. Substitute a midpoint back into the original rounding statement to verify it would round correctly.
For parents or teachers listening, explain bounds as how much bigger or smaller the real measurement could be because of rounding. Use a simple classroom script. To get lower bound, subtract half the unit of the last digit. To get upper, add half the unit. Then use less than or equal to for lower and less than for upper. Keep that checklist on a sticky note for practice tests. And for teachers marking homeworks, quick checklist. Did the student write bounds for every rounded value? Did they use the bounds in the calculation? Did they state the final interval with the correct inequality signs? Tick off marks even if the final single number answer is slightly different. Method earns marks. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a printable bounds checklist at jcacademyonline.co.uk. Visit the link in the show notes for a downloadable worksheet with step-by-step examples and marking guidance.
I'll stick that checklist on my desk before the next mock. Thanks. Feels less scary when you break it down.
One last tip. Encourage students to write the word bounds on their answers. It signals to the examiner you've used the right approach. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.